10:30, so it's time for us to start the webinar. First of all, let me welcome you on behalf of Prem Jain Memorial Trust. My name is Ashish Rakheja. I'm one of the trustees of the Prem Jain Memorial Trust. Let me give you a little brief about what the trust is before we go on to the activities today. Prem Jain Memorial Trust was started in the memory of Dr. Jain, Dr. Prem Jain, who was a renowned consulting engineer with over 50 years of experience working here in India. In fact, some of the industry members also regard him as founder of the consulting business in the country. During his tenure, he designed the most famous buildings in India, starting from the Darbar Hall at Rashtrapati Bhavan to the Indira Gandhi National Center for Arts and many, many other buildings. After demise of Dr. Jain, the family members and some of the industry members decided to carry the message forward for what Dr. Jain believed in and set up this trust. Dr. Jain was also the chairman of the Indian Green Building Council, and during his tenure, the council grew its footprint from a mere few thousand square feet to nearly 7 billion square feet due to the vision that he had set. Dr. Jain is also regarded as the founder for the Indian Society of Air Conditioning Engineers and for bringing the ASHRAE chapters to India. His work in the field has been unparalleled and is remembered by many today. The main mission of the Prem Jain Memorial Trust is to identify future leaders and be a catalyst for sustainability. Dr. Jain believed and loved students, and that is why the focus of the Prem Jain Memorial Trust is also students. This series that we have been running now for 3 weeks in a row, this is the 4th edition of the six talk series that we have. We call it a living building series. It's an intent to showcase the future of buildings. Buildings have traditionally been regarded as an entity that has a negative footprint, whereas the intent is going forward, the building should be having a positive footprint on the environment. And that's the reason why the Living Building series is running. In the last 3 editions, we had speakers who came in from various facets, talks about the net zero energy, the complete facets of what a living building should be like, and the other areas were covered. There was a growing demand, which we heard in the questions that we got, and also the feedback that came to us, that we need to cover the other aspects like water, waste, and going forward. So this edition, the 4th edition that we have a wonderful speaker coming from Delhi. He himself had been associated with Dr. Jain. In fact, he was a young engineer that I know of, came out from IIT Delhi, and Dr. Jain helped him to guide his career, and he became an expert in the water conservation. Today, the speaker that is going to come is going to be addressing to us about how the water conservation is important. One of the, if you want to know more about the Prem Jain Memorial Trust, please go to the website. It's there. It's coming. You'll see the address on the website address on the screen. Make sure that you visit and reach out. All the talks that have happened so far, the 3 in past, they have been uploaded on the website. They are available for you to download them. And besides, the questions also which are asked are passed on, the queries to that are also posted on the website. We have a green icon called Green Know everything about green. And the Green Know is answer to anyone who's looking for any solutions, any responses on what the sustainability is all about. You are always welcome to write to us on the Green Know on the website, And one of the experts, the members who are panel members of that, will respond to you suitably thereafter. So I'm going to move on now to Dr. Hariharan, who's also one of the trustees of Prem Jain Memorial Trust and is responsible for bringing the various colleges that are currently attending this webinar. The colleges come from Bangalore, Mumbai, Cuttack, Bhubaneswar, Mysore, Mangalore, Chennai, Delhi, and across the country. We typically get about 300 to 500 people which listen to this webinar, and most of them are students. Coming back to Dr. Hariharan, Dr. Hariharan is a pioneer in the green buildings. He began this, since 1990s, he's been around and working on the green buildings and environmental practice. He calls himself an environmental economist, writer, and a builder. He has founded and built businesses in past which have focused on zero energy development and pioneered the green directions which were way ahead of time. BCIL and Z Homes were part of his work in the past, and those in Bangalore would know him well because he keeps, we keep hearing about him on many, many forums. So Dr. Hariharan, over to you. If you could give a brief about what the subject is and also introduce our eminent speaker today, and thereafter we move on to Rajesh for the talk. Before I hand over, just a word that during the talk or afterwards, if you have any questions, please post them on the question and answer, the Q&As that you see at the bottom of the panel. Please do not post them on the chat because we'll be monitoring and administering only one of the boxes, which is the Q&A box. So you're welcome to ask questions, and between Dr. Hariharan and myself, we'll pose the question to the expert, which is Mr. Rajesh Jain, and thereafter you'll get the responses. So over to you, Dr. Hariharan.
Thank you. And good morning to you, Ashish. Thank you for that very crisp and very, shall we say, experiential kind of introduction to Dr. Jain. You know, you moved me when you talked about the sort of work that he did. I know you have a very deep attachment to him. Namaste to all of you. Thank you for being here once again, this time for the 4th edition. This last, say, 3 or 4 weeks, thanks more to the lockdown than to the virus itself, we've all experienced how some things have surprisingly changed so much for the better in such a short time. We have cleaner air and water, we have nature thriving, we are discovering family, and we are recalibrating our work rhythm and pace. We are also reaching out more deeply into our own communities. If you're living in apartments, you would understand and relate to what I'm saying. I wish Dr. Prem Jain was around to see his Ganga running as clear. In Kanpur, the temple priests have reported that they take a bath in the Ganga, and this after 50 or 60 years. Jamuna, the powerhouse in Delhi, those of you in Delhi will relate to this, is running crystal to the bottom. You must have seen such video films that someone or the other has posted. And there's a tide of such webinars on the environment, people putting their heads together in deep sharing as we are trying to do here today. He would have been really heartened to see this groundswell of such good things. Dear students, this is a session primarily for you. While I acknowledge that there are many working professionals, many industry leaders who have come in today for this session. This has the chairman and vice chairman of the IGBC also who have logged in today. Mr. Suresh and Mr. Gurmeet Singh are there, as well as many other industry leaders. The fact that this session has so many senior green professionals and veterans shows the particular keenness that these leaders share in you and in your futures. Primarily, I'm addressing this to the faculty. You need to understand that every one of us here in industry are concerned and want to see how we can help you. We will keep this session very simple and easy to understand for you all. Let me at the outset tell you that there are special concessions for any of you students of architecture or engineering or even MBA programs. If you want to take up the IGBC AP certification, I would request all faculty to get in touch with architect Sakshi Jain, who is the principal coordinator at the PGMT. On your chat box, you will soon see her mail ID. She will counsel you on how you can become accredited professionals, and she will guide you to those officers at the IGBC who will then guide this process for you. This Living Building series, which will bring you many teams and leaders over the year to speak to you on different themes, combined with an IGBC AP that you can take up, will make you a winner for the future of your own career and, of course, for India's green needs as it evolves its economy and shapes the destiny of its 1.3 billion people. My special thanks to some of the dedicated faculty leaders who have been in touch with me at all odd hours in the interest of your students. Count on any help we can offer you all at the PJMT. Sakshi or I will direct things for you. You know who I'm speaking about. I don't want to take names here. Many of you have been consistently speaking to me to see what I can do to help you all. For those of you who are newcomers to the Living Building series and to this Near Zero dialogue, you can visit the link that shows up on your chat box. Visit those presentations hosted at the website, beginning with the first one that Ashish presented, which was more to do with air management and buildings and energy. Then came a broad overview of all these 6 elements, as I believe, need to be sort of addressed when it comes to a building. We had then a veteran and doyen of energy called Padhu Padmanabhan, who is also here in this group today, as I noticed, who came in on the larger aspects of the source of power and the challenges of the grid as we walk into the next 20 years of India's economy and its needs of powering industry, agriculture, and the urban sector. If you visit those presentations, that will make a difference to you. Thanks to all the students who have responded to those 5 questions that are part of the reference reading. I sincerely hope you read the notes that we took time to prepare. It's all there on that link that should be appearing on your chat box now. Please visit those and see. If you haven't actually studied the reference reading material, I would urge you to spend some time upon it and to also see that you, for your own sake, answer those questions. You want case studies. You want real scenarios of business. Well, you have to then study all that is already been offered there and will be over the weeks to come. Ask questions of us. That's important. That will help you learn. And that will help us also see secure insights into how you think through processes of learning that your faculty is offering you. I will request faculty heads to guide this for your students. Your believing in this series is vital for students to gain from it. We want to see that we raise the benchmark. We do not want this to be just another webinar. Please help us to make this qualitatively superior. I have about 5 aspects to share today before I invite today's speaker, Rajesh Jain. This time, I have my usual 10 minutes of some important reflections. There are 5 parts to this. Let me start with you with a very quick story. In January this year, about 100 apartments were served notice by the Bangalore Water Supply Board. Resident welfare associations, as they're called here in Delhi and Bombay, they're called societies, were warned with notices. The message was either you set up sewage treatment plants for treating water, or we will not permit dirty water from your apartment to flow into the sewerage drains. Associations filed protests. They insisted they had paid deposits to the board and had the right to spew all their dirty water from their apartments into the city's nalas. Were they right in asking for their legal rights? Was the Water Supply Board wrong in bringing in some penal measures of that kind? There is a raging battle that these resident welfare associations, as they are called in Bangalore, are having with the board. Is there a larger issue that apartment societies and RWAs are blind to? If you are living in an apartment in any city, should you be worried about the long term of water itself? At the global level, water access is an alarming concern. A child dies every 8 seconds somewhere in the world thanks to polluted water. 1 billion people have no water access across Africa, across India, and of course, certain parts of the rest of the world. In many districts, you and I know, people walk long miles to fetch a bucket of water for the entire family. In Rajkot district in 1993, when I did some work in Raj Sandhyala, a small village about 60 kilometers west of Rajkot, people paid 10 rupees for 1 bucket of 20 liters. India tops the list on water deficit nations in the world. Our cultivation water demand faces a very serious crisis as we go into the new decade of the 2030s. Rajesh will also briefly touch upon that in his presentation today. Budding engineers and architects should look at career options in the development sector beyond these buildings in the city. At the Prem Jain Memorial Trust, we will counsel you, all of your students, on such directions if you want us to. Please write to us. In the 10 to 12 months before the lockdown, I've had many requests from our partner associations for helping them solve this challenge of securing fresh water and getting rid of wastewater. In the last 4 to 5 weeks, and listen to this carefully, as the early summer set in Bangalore, tanker water suppliers doubled prices of water sale from about 130 to 150 rupees per 1,000 liters to about 300 or 330 rupees per 1,000 liters in the last 2 weeks. This means approximately about 15 to 30 paisa per liter in some parts of the city. Against this, the water utility in Bangalore costs about 80 rupees per 1,000 liters or 8 paisa. And water drawn from a borewell in an apartment is even cheaper at about 40 rupees. The Water Supply Board in Bangalore, for example, pays as much as, on the cost side, about 93 rupees or 9 paisa, while they sell it to us at anywhere from 6 to 8.5 paisa. Now, the cost of just transporting water in Bangalore from Kaveri, which is about 83 kilometers from here and about 500 meters below Bangalore's plateau, claims 9 to 10 paisa or about 95 to 100 rupees per 1,000 liters. You must remember that on a plateau of this kind, as in Pune, for instance, the cost of energy becomes a major challenge when you have to transport long distance. Delhi or Calcutta or Bombay are also dependent on long distance water. Aurangabad has had Jal Nigam offices stoned by angry mobs when the municipal corporation decided to reduce pressure or the duration of water supply. And this applies to many towns across the country. Water is sold almost always by water utilities at a loss. Users don't feel the hurt because it is so cheap that you don't even know how much you pay per month. Not having water is a challenge. Delhi charges a mere 36 rupees per 1,000 liters today. Mumbai is worse at 20 rupees per 1,000 liters. What you don't realize is that you pay about 50 to 70% of this drinking water cost for sending dirty water back from your building to the sewerage drains. You must look at your water bill back home. Ask your father to see if he can offer it to you and study the bill to understand how these are sort of taken up there. Now, there's a clear need. You can see this in our cities for understanding why we use fresh water only once, when technology has transformed in maybe the last 10 years to turn used water into pure drinking water. Even in industry, I'm seeing that people are not still pushing the membrane of such economic possibility to get dirty water to become drinking water. You heard that right. You can today drive all the toilet and kitchen and bath water from your house to a water treatment system that can get drinking water out of your own dirty water. Singapore has been doing it from 2008. China has over 400 cities which run on such simple technologies. And they don't even question the prospect of turning such water into drinking water. When you flush down the poop every day down the toilet, you must consider what you're doing to about 100 to 130 grams of such human biomass that you flush with 6 to 12 liters of water. What happens to that water? How much, if you actually had any chemical engineer look at it, and Rajesh is a chemical engineer from IIT Delhi, you will see that there is no more than about 1% of all that water which is organic. How do we now move toward treating such waters in a way that we do not have to look for long distance options into this future before us? Keep that as a question. Look at the reference reading material that we have offered. Answer the questions that we have also asked. Understand the size of such a challenge in, say, your apartment. Maybe you want to look at the campus of your college and look at the numbers. Rajesh will also present to you some of the per capita numbers, depending on whether it's a hospital or a home or an office and such. I will only say this to you. Delhi today has about 320 crore liters that it gets for its population at about 130 liters per day. But it loses about 40% or about 120 crores on that 300 plus crores every day on simply leaks and thefts. Is this the kind of centralized water system that we want to have into the future? You are the young architects and engineers who will shape these destinies as we go into the next 10, 15 years. The figures in Bangalore are at about 135 crore liters against Delhi's 300 plus. And in Bombay, the figure is at about 250 crore liters. It is absolutely unsustainable to continue to think that fresh water should be used only once and drained. Think this out. You shape the next phase and the conversation itself on how we should be dealing with water into the future. Can we solve this together? Can you make your apartment, or well, if you are somebody who is running a factory among the working professionals here, or a consultant who is guiding such factories and office buildings, can you make those buildings into near zero water buildings? How do you get all residents in a city ward beyond your building or an area to work together? If all of us did well on retention of groundwater, for example, with good practices of not using borewells or recharging borewells and harvesting rainwater, that will help meet at least 2 months of our need. I don't want to delve far greater into detail, although I know many of you in the faculty and the students who have sent us feedback forms want us to give you specific solutions. I'm reminding you once again, please look at all the case studies that have already been offered in the 3 series of reference reading sections that are offered on the PGMD website. Net zero energy or net zero water or net zero waste is a good goal to achieve for any building, existing or new. I would say, look at existing buildings. We have today in India 160 billion square feet of existing buildings. They call it building stock. If you're an architect, you'll understand what I am saying as an architect student. Now, that figure of 160 billion is set to go up to about 400 billion square feet by about 2035 or 2040, depending on who is making what kind of estimate. Think about that too. So if you want to look beyond these buildings inside cities, what do you think we should be doing on the agricultural front? What do you think we should be doing on the industrial front, especially where industry is, or industry segments are water intense? For example, to produce just 1 megawatt of power, it costs any thermal plant, which is coal-based, about 30,000 liters. And the figure can be absolutely staggering. If you look at the kind of draining that we do of the groundwater resources in those forests of Chhattisgarh or of Jharkhand, you will be shocked into wanting to see if you can carve a career in those directions of developmental India. I will leave the floor now to Rajesh Jain. I repeat Ashish's request: mute your audio and video, use the Q&A window and not the chat box. Debarti, there are some people who are asking on the chat box as to why they are not able to hear us. I think you should see if you can respond to them. To all faculty and some students who have responded to the feedback forms we sent out, thank you so much. I'm so glad and grateful to you all for offering us insights. That helps us to shape our future programs also better. We've been learning from your responses. We are trying to keep it as simple as we can in trying to explain the think approaches. My last notes, well, what do I want to tell you about? You see, look at it like this. Someone asked me this question, and therefore I'm sharing this with all, particularly with all the faculty. If I walk into a hotel, into a 4-star or 5-star hotel, if I were to give you only 15 minutes to find out what the water demand of that hotel is, how would you go about doing the math? Think about it, dear student. I will leave the question with you. I'm not going to answer this. This applies to materials we use in a building. This applies to energy we consume in a building. And of course, the waste we produce. The next week we have got, as part of the series, the theme being near zero waste and approaches in cities as well as in buildings. That will be a treat for you all. Water is a larger and a grimmer story, as I said. Every such deficit is an opportunity. Water as an industry has been growing at over 25% year after year in the last 7-8 years. Think about making a career in these areas. Thank you again for all of those who have logged in. I'll hand the mic over to Rajesh. Rajesh Jain, can you take over now and share your screen, and we will get forward.
Sure. Yeah. Thank you, Dr. Hariharan. Thank you for your kind introduction, and you made my job easier by giving so much of data on water and the need of recycling and conserving water. Thank you, Ashish, and the whole PJMT team for giving me this opportunity. I'm so grateful. And this presentation is a tribute to Dr. Jain, whom I had met in 1995. And then, of course, as Ashish said, he guided my career because he saw the passion in me, but no direction. And that's how he directed me to start working in this area. And I'm so grateful to him that I've been able to follow my passion and discover, of course, new things as I went along working on different types of projects. So I'll just share my screen and go on to the subject. Is it? Yeah, is my screen visible to all?
Yes, we can see that, Rajesh. Go ahead.
Okay. So good morning to all of you for joining today morning and showing your interest on the subject. And I'm sure a lot of these young architects and a lot of professionals will gain from some of the insights we'll discuss today on water, as water remains a critical concern for all of us. And especially during this pandemic, the water has gained even more importance because we have understood the role of water and hygiene, because when we wash our hands every 1 hour, every few hours, we need clean water. So my subject today is net zero water, design of building. First of all, the question would come to everybody's mind that is it really possible? Because most of the existing buildings consume a lot of water. All the campuses and buildings we have worked with, they consume a lot of water. So how is it how can we achieve this net zero water when we design a new building? So I really believe in what Dr. Jain said, that if we can all change our thinking towards the buildings, maybe we will build what will change the world. So whatever we build in the future, we should be able to change the world. And this series has highlighted a lot of possibilities in energy, water, space. So let me go along and share my whatever I've been able to crystallize this into a very simple approach to water management. And if practiced, I'm sure we'll get wonderful results. So, yeah, so sustainable water management. Dr. Hariharan spoke quite a bit about all this. And we all know that India is running out of water. Many cities have depleted groundwater. We saw Chennai, last season, Chennai had social unrest and a lot of hotels were thinking of shutting down because of lack of water. We also heard of Shimla about two seasons back, ran out of water in the peak summers, and the businesses had to be closed in Shimla. We heard about Cape Town reaching, 0 day. Similarly, we are now saying that 21 cities, and of course, cities like Bangalore, Chennai, Hyderabad, many of them are now running out of water. So what is happening is, water demand is rising because of rapid urbanization, a lot of construction, and India, see, all the cities are service economy, and India's service economy is contributing to almost 55% of the India's GDP. Obviously, which means that there are a lot of job opportunities in the cities, and everybody wants to move into the cities. So because of that, water availability is reducing and water demand is rising. When I look at, of course, in a very simple way, I'm presenting the global scenario. When we looked at different countries, when I looked at Canada, which is, very small population, have 20% of the water resources, fresh water resources. When you look at Brazil, has a lot of water resources compared to their population. But unlike India, which is, already having 16 to 17% of the world's population, but only 3 to 4% of the fresh water resources, and which are also not available for usage. They're there in the form of glaciers and things. So I just thought, I'll just compare and put into perspective, let's compare India and China and see some numbers how China is faring and where India is today. So in terms of population, we are almost similar. In terms of geographical area, China is almost 3 times of India's size. Urban population, of course, China is much more urbanized, as Dr. Hariharan mentioned, that there are 400 cities. In rural population, India is higher, but of course, it is rapidly getting urbanized. India also has now almost 450 cities in the Amrut government scheme, which are under various phases of development and growth. In terms of agriculture, of course, India's productivity is much lower, almost half of China's productivity in terms of area yield per hectare. And in terms of water resources, we are 4% as compared to 7% in China. And of course, we all know about Singapore, how Singapore is managing water. Singapore had to, borrow water till some time back from Malaysia, and when Malaysia started threatening them on sharing water and all, so they had to really create this vision of next 100 years, how they will manage water. So they not only looked at seawater desalination, but they are recycling all their wastewater. Literally, they have achieved zero discharge as a country. They are doing a lot of rainwater harvesting, and I think the breakup almost is 33, if I remember it correctly. If you know about Israel now, which is a desert country, how they are able to survive, and have prosper in a desert. People who have given a sincere focus to water are growing and are able to, because ease of water also contributes significantly to the GDP. So if you don't manage water well, there will be a loss in the GDP, and there are some numbers of 5-6% people talk about. Of course, so I'll go along and share about my ideas about cities and buildings. So when we look at cities, what are the resources we have? We have water bodies, and most of them are polluted. Like Bangalore, most of the lakes are polluted. Our Yamuna and Ganga, which of course, water is a living being. Today, during this pandemic, when hardly any pollution loads are going into these water bodies, all the water bodies have cleaned up on their own. So if we really make sure that we don't pollute them, they will revive on their own in due course of time. So, but yeah, currently today our water bodies are polluted. Our groundwater has depleted in most of the areas. Most of the places come in the green zone, like the city I live in, Gurgaon. You can't draw groundwater even for construction. You have to use recycled water for construction. So groundwater is even Bangalore and a lot of cities, groundwater is not available. Like Bombay, groundwater is not available. It is very saline. So and rainwater, we are still not managing it very well, because most of during the peak rains, most of the water runs off and goes into the drains and or floods the city and etc. So we still have to really discover how do we manage rainwater during the rains. But one of the resources which I found, which is widely available to all of us, is recycled water. As we discharge almost 100 to 100, each person discharges to 100 to 110 liters of wastewater per capita. If we can manage this water well, we can almost meet 80% of our requirement on a day-to-day basis, and then it may not be difficult to get the balance 20% from by conserving rainwater and harvesting rainwater and managing our groundwater and water bodies well. So, and as we also know that in terms of water supply, what is growing today is the tanker water supply, because municipal supplies are not growing. Most of the cities do not have enough water. Like Delhi, I know does not have water, more water to augment their water supply. The only way Delhi can really manage is by conserving water, by reducing the losses, and by recycling the wastewater. And same is true with most of the cities like Bangalore and all. So let me go to the next slide and share, what are the options we are left with in this scenario. So, see, most of the cities have grown in terms of population. So we always, in any city, any large city, there is a core part of the city which is old. So we call it the old city. then there is a newly developed city, and then there is a to be developed city, because every city is growing. So I've divided the whole city into 3 zones, and when I look at the wastewater as a resource, what I find is that we have a lot of opportunity, but some constraints. Like the old city it may not be feasible to have decentralized wastewater systems and local recycling systems, because there may not be any place to set up such facilities. But the new city, which has come up recently in the last 10-15 years, there are a lot of these projects already have decentralized wastewater treatment systems, and they can, if they are not recycling 100% water, they can look at this opportunity and save a lot of water for the city. But yes, there are a lot of infrastructure and a lot of places where the water still may not be treated and recycled. So you will always look at a combination of centralized and decentralized systems for this part of the city. But the newly to be developed city, now you young architects will be designing a lot of these buildings which are going to come up in future. So if we really make up our mind that this to be developed part of the city, all the buildings will have zero discharge, and they will meet all 100% of their water requirement on their own by managing their wastewater and rainwater harvesting. It will be quite sustainable. The good thing will be the government will not have to spend money in providing the infrastructure in terms of water supply and in terms of wastewater disposal or drainage for wastewater or stormwater. So, and government then can focus more on improving the infrastructure in the internal part of the city. So, and of course, how do we incentivize this sort of a challenge? When I was thinking about this, the idea which came to my mind is, see, if each project is sanctioned, and this is of course a policy matter, if each project is sanctioned based on the water demand, and they allow only that much of population density per square meter of the area based on the water demand, they should be able to, and this can become a good incentive to the developers, that they will try and reduce their water demand because they want to maximize their revenue through construction per square meter of the land they buy. So yeah, what I also found is that when you have decentralized systems, you can almost recover 100% of your water, but when you have centralized and systems, you can recycle only 20% within the city. Most of the water has to go into as industrial water makeup or in agriculture, as it happens in the West. So this is where we again lose the opportunity. So when we look at the city, what is city built of? City is built of various types of buildings. Now, all these buildings have different architecture. Some of them are tall buildings, some of them are large campuses, some of them are air conditioned, non-air conditioned, different proportions of green area, and so different opportunities lie in different projects. And based on the occupancy, some buildings have fixed occupancy, some have variable occupancy, like hotels have variable occupancy, malls have variable occupancy. So there is some challenge in terms of designing it well, and that's why when we look at the design aspects, which I'll be sharing subsequently in some of my slides, we need to look at the round the year consumption of water. It's not just one season or the peak demand. We need to look at summer, winter, rainy season, and what is the water demand round the year. And based on that, we can properly channelize our investments into infrastructure which is required to conserve water. So as this slide is saying that, if we need to be water efficient, then each building needs to be water efficient. I hope I'm audible. Yeah. So when we look into the buildings, we want to look at how to go about it. So what I understood is the best thing is to learn from the existing buildings, and let's visit and audit some of the buildings, and let's see how their water consumption is and where they are wasting water and what are the opportunities which are there. So learning from that, if we incorporate those in the new buildings at the concept stage and design and construction stage, then of course we would achieve our objective. So this is what I'm trying to, I'm going to discuss both aspects of how to manage water in an existing building, and as well as how do we design the new buildings. And of course, how do you make sure that whatever you've designed is being delivered and being maintained. So, of course, we are talking about IoT, AI, ML, and all this dashboard-driven operations and all. This will become quite relevant in today's time, and increasingly it is being used in water management as well. So, in this slide, I'm sharing some of the norms for water supply, which we follow as per the National Building Code, and different types of like domestic water, as Dr. Hariharan shared, that it is about 135 LPCD. Of course, some societies consume much more than this. I've found some societies in Delhi consume almost 250, 300 liters per capita. But yeah, this is a good average, and if we look at the breakup and calculation for this, it makes sense. Hospitals are 340 liters or 450 liters per bed. Hostels are again, residential hostels and boarding schools are all 135 liters per capita. Hotels are 180 per person, per room per person. Of course, it goes to 360 for double occupancy. But since hotels have a lot of other infrastructure in terms of restaurants and laundries and all, I've seen the consumptions are as high as 500 to 1,000 liters per room in some of the hotels. Restaurants are 70 liters per seat. Looks high, but yeah, that it is. Offices are 45 liters per capita. Cinema and concert hall is 15. Concert hall is 15 liters, and day schools are 45 liters. So these are some of the norms based on which we design our buildings today and design our systems today. So when we look at the existing buildings, what do we find? We find that there are a lot of losses in the system, and obviously when we started looking at sewage treatment and recycling, somewhere the bias came in our mind that we can only recycle treated sewage water only for secondary applications like horticulture, cooling tower, makeup, and flushing. A lot of places, I even know till today, we don't even recycle water black in flushing and cooling towers because of the quality concern. But it is now generally being practiced as water is becoming more expensive. But after that, also there's a lot of water which gets drained out. In Delhi, the air conditioning system stop in winters. December, January, almost there's no air conditioning going on. Even November and February, it is much less. And we found that most of the treated water from STPs were being drained out. So there's a lot of excess water which is flowing out from this premises. And then there are a lot of apparent losses. The losses are when we design the systems and we go for certain systems like softeners. The regeneration water from the softener, which has very high TDS, cannot be recovered and reused. Then there are cooling tower blowdowns, there are RO rejects. So a lot of this, sometimes we don't recover the filter backwash, and a lot of unrecoverable water makes up for the apparent losses. Apparent losses are the losses which we can quantify. If we survey a building and see the systems, we can easily quantify what is not being recovered and reused, and what is going out in the form of apparent losses. So when I look at, when we try and correlate the freshwater demand of existing buildings, or what we saw is that there is a correlation, very simple correlation, which I'm trying to show here, and I'll go in little detail of this equation. So freshwater demand is equal to AC evaporation. So this is where the water energy nexus comes in. The more air conditioning we have, the more air conditioning load we have. Like in summer we have peak load, and in winter we have less load. Your water demand will vary. Freshwater demand will vary based on that. And I'll further come into this particular parameter. The next one is horticulture demand. See, these are waters which we don't flow back in the STP. So this water gets lost. AC evaporation water, cooling tower evaporation water gets lost in the air. Similarly, horticulture demand, the water gets lost in the soil and percolates down or evaporates. And then plus the apparent losses, which I just shared. What are the apparent losses? Hidden losses, of course, every system has some hidden losses. and sometimes we can't make out, but the general norm is 5%, less than 5%. International norms are 2 to 3%. So I can presume that 5% is a good assumption. And then there's an excess water drain from STP. This is the scenario today. So how do we now, if we understand this, how do we take it further in designing new buildings and making sure that our existing buildings also become more efficient? And there's a huge opportunity which lies in the water space. When we talk about energy, we talk about 10-20% savings. When we talk about water, the savings come to sometimes 40-50% and sometimes even higher. Huge opportunity. So when we looked at some of the buildings, hotels, commercial complexes, housing and all, we found that if we follow this equation, we validated our equation and we follow this equation, there are many advantages. First of all, it is very quick. We can very quickly estimate, as Dr. Hariharan pointed out, we can very quickly estimate that what is the minimum freshwater demand the building can have. If building has zero apparent losses or no water is going out of the STP. It's very quick. Within 15 minutes, you can actually check, what is the minimum possible water demand. And once you know that, then we can really see, how do we approach that and what are the priorities to address which item will need more investment, which item will need less investment, and what is the operating cost, etc. And we can really try and achieve the minimum possible freshwater demand. Now, when it comes to designing a new building, if we follow this, this is where the core of my focus lies today in terms of explaining to the architects and engineers what can be done in terms of water conservation when we design the new buildings. So when we design a new building, when you design an envelope, of course, when you're looking at net zero energy, you're already taking a lot of measures of passive architecture, a lot of technologies which are energy efficient, and we raise the temperatures today inside the building so that the heat loads, rejected heat loads are less, etc. And that's how you look at reducing your AC evaporation. And AC evaporation also happens when we go for water-cooled chillers, because water-cooled chillers are more efficient. They're designed on wet bulb, whereas the air-cooled chillers are designed on dry bulb. So sometimes if there is a real need to go for net zero or water positive designs, we can also look at air-cooled chillers. Air-cooled chillers consume more energy, but in summers, but they consume less energy in winters, and when the wet bulbs are low, when the dry bulbs are low. So, so when you design an envelope, you look at air conditioning demand around the year and calculate. The calculation is as simple as 8 to 10 liters per hour per ton of refrigeration is the water required in general for AC evaporation or cooling. Then we look at area and we look at the horticulture demand, and we can see how to reduce this through drip irrigation, through planting species which will need less water, can survive on less water, and we can assume some hidden losses of 5% when we are designing the building. And in the beginning, we can safely assume that the apparent losses will be zero, can be zero, because I'll again explain this. And excess water, we are all recovering all the STP water around the year by treating this water to the drinking water standards, which is not difficult, as Singapore is doing, and there are a lot of case studies in India as well. So this way we can really look at the water demand reduction, freshwater demand reduction, and and really play with it in your design. Through a few iterations, you can optimize your design to a point where you're happy that yes, this is good, and this much water you will be able to harvest and store and supply as makeup water and make it net zero water or water positive. So of course, this some graphs I'm showing here is only indicative that what are the opportunities which lie in today's buildings, whether it is a commercial building or a hotel or a residential. My main focus is on this equation and use of this equation when we work with existing buildings as well as the new buildings. So as I'm sharing in this slide, 50% of the losses, generally the losses are to the tune of 50%, which can be easily saved. Sometimes sometimes you face the challenge of high TDS water, and especially when your raw water supply is, see, when you have consumptions to the tune of 500 cubic meter, 1000 cubic meter per campus and per building, obviously you can't harvest so much of rainwater. Then you depend on tanker water, you depend on borewell water, and sometimes the TDS and hardness of these waters are high. And you have to go for an RO to treat the bulk of the water and supply good water in the building. So in that situation, sometimes when we are not able to reject all the TDS in the horticulture, because horticulture can take high TDS water up to 2000 milligrams. If we see that we are not able to achieve this balance, and then sometimes we have to go for an additional technology where we optimize the whole design and go for a MBR unit, which is widely being used in the industry, where we evaporate the water and condense the pure water. The salts are separated. But if we again smartly design our water management system, this may or may not be required. This is just a to give a complete picture of how zero discharge can be achieved in every scenario. So I'll also, in this slide, I'll share the month-wise data of some of the buildings. So I'm just trying to indicate here that why this is important to look at the full year scenario, because a lot of times I've seen that we only look at 1 day scenario, peak, and we show that the building is achieving zero discharge, which is not true. We have to look at, and this table will show that sometimes the savings are much higher in winters, and your water demand comes down significantly. Summers, of course, it is less, as I'm showing in April, May, June, July. And if you look at December and January, the November, December, January, it is high. Savings are very, very high. So I hope I have been able to make some sense in terms of designing the new buildings, as well as how do we manage water in the existing buildings. Now the challenge really lies in that we don't trust our STPs in terms of design and in terms of operation. And as slowly the government is making the norms stricter, like recently the discharge norms were revised by the government, and now the new norms are BOD less than 10 and COD less than 30. I'll not go into detail of all these parameters, but these are the new norms and a lot of STPs will have to upgrade to these norms because they can't even meet these norms today, the old ones, but the new ones are trying to design based on these norms. And there are a lot of recyclable water desired. What is the desired water quality for different applications, secondary applications like horticulture, cooling tower, and flushing? And most of us try and meet these requirements by managing or maintaining our systems well. And the next now, as per my talk today, the next challenge lies in how do we recover 100% water? And if we treat the surplus water into health grade drinking water and drive that water back into the domestic water tanks, we will be able to literally achieve zero discharge in terms of excess water going out of the STP. And then we need to also look at the TDS balance and see whether we need to do something additional to this to finally achieve zero liquid discharge and minimize the freshwater demand. This is another case study I'm trying to share on the housing society. Maybe you're quite, because most of the societies are not able to, even if they have a STP today, they are not able to recycle most of the water. The recycling is to the tune of 30-40%, sometimes 50-60% if your horticulture requirements are high. So a lot of water gets wasted. So as Dr. Hariharan just mentioned that how tanker water costs are going up in summer in every city. This is a huge opportunity, can have a very attractive ROI. If in this slide I am trying to show that how the freshwater demand of the society of a housing society, which was originally 226 KLD, can come down to only 39 KLD kiloliters per day if you recover all the water and flow it back in the freshwater system. So of course, in this design, I'm trying to show that we can have dual single discharge and single supply, but of course we can always play with the options of dual plumbing systems, dual discharge, dual supply, etc. And different options will have different advantages, and the decisions have to be taken on case-to-case basis. So so far I've shared that how do we focus on reducing the freshwater demand by reducing the apparent losses, recovering all the water from the STP, and then how do we, reduce the water demand in the air conditioning at the design stage, or look at the horticulture demand, etc. So the water demand can come down significantly. Then what are the further strategies to be looked at when we look at net zero or water positive design? So a lot of us are following a lot of demand side strategies. We're using water efficient fixtures. Recently, there's a lot of nozzles which have come, which you can fix in the tap and really reduce the water from the oozing out of the tap by 90%. Then flow meters. Somebody was sharing this data with me. There's a straight away reduction of 35% in water demand when you have a flow meter. When the water consumption is being measured and monitored, then of course everybody becomes conscious and starts saving water because they have to pay as per the meter reading. So these are all on the demand side. Now, when you look at the supply side, what are the options we have? The options we have generally are rainwater harvesting. Now, we have been a lot of us have started doing rainwater harvesting in our campuses and buildings, but I don't know how well they are being maintained is one issue. Second is none of us are really looking at storages, and because the storage costs are high, if you store the water in open, it evaporates, and also storage still remains a challenge. And this is where I would ask the architects to innovate, that how do we do storages below the ground. I've seen some concepts and buildings in the West where they store the water below the building and for around the year. And we even saw in Rajasthan, from where I belong, that in Rajasthan the water used to be saline, and so you can't have when there were no water supplies from the government. The only way you are forced to drink the saline water or you store rainwater, and we used to store rainwater for around the year usage and comfortably live. So storages has to be looked at, and the economics of storage and supply. What I generally recommend is that you should have some storage at least for drinking water supply, because each person consuming 3 to 4 liters, including the kitchen demand, we may consume about 10 liters per capita, and we can design our storages for 3 months, 6 months, or round the year storage, depending on again the cost and budgets we have. So that's where what is on the supply side, and some of the points which I've already shared are STP treated. We can segregate water in gray and black if it makes sense. And gray water is much easier to treat to health grade water in some cases. But yeah, then the piping and management of 2 plants becomes a challenge. So the choice remains with us whether we want to segregate or we want to have a single sewage treatment plant and single health grade water system. So these are some of the opportunities we have to achieve net zero or water positive design. Now, how do we? I've already shared this most of it, but how? So that this is where the architects generally play a key role in water management. Of course, the water systems are being designed by the engineers and the consultants, and they have to mandate. The architects have to mandate, the clients have to mandate that this is what they want to achieve. But architects play a key role in designing the rainwater harvesting structures and storage systems when they design the buildings. And as again shared already, a lot of water you can harvest. As some of my points are showing that 60% of your requirement in a house can be met if you harvest and store the water. And of course, it is much cheaper, very low TDS. When you actually use rainwater as a makeup water, you don't have a TDS challenge at all. You don't have to go for very expensive or very high operating cost technologies like MPR. You can manage without them, because if there are certain ratios we follow in terms of depending on the TDS, what is the ratio of water consumption in air conditioning and horticulture. We can easily manage the TDS as well. So yeah, Dr. Hariharan already shared the costs and advantages and the ROI of all this in the time to come, since water is becoming more and more expensive. So I'll now summarize whatever I've shared quickly, but I hope I could really spell out what I wanted to share. But I'll again, recap the whole discussion and try and put it very in a simple way. So when we look at new designs. So how do we achieve net zero and water positive design? So the first step is we can, when you design a building, because the system designs always happen later once the buildings are designed. So when you design a building architecturally, you can safely assume that apparent losses can be zero, and excess water, you will not drain out excess water from the STP, so they become zero. So then you can quickly estimate your freshwater demand in terms of air conditioning demand and horticulture demand and hidden losses, and you can play with this number by changing your design, and with few iterations you can actually optimize your design through passive architecture and a lot of different strategies. And of course, Ashish is a very eminent consultant, and a lot of you maybe in future working with Ashish and team. So you will be looking into all this with consultants, air conditioning consultants. The second step is minimize. Then once you have this first-hand data on what you are designing on, then you can try and optimize even the AC evaporation, reduce the air conditioning load, reduce the horticulture demand, look at the right strategies of drip irrigation, plantation, etc., and bring this down to a point where you feel that you can become water positive now. And of course, hidden losses in a new system will always be low. And we can have we can build this IoT technologies to really even account for how much is the hidden loss. Today, most of the time, we don't know this what is the hidden loss. Then the third step is look at the design for all the seasons, full year. Once you have this data, then when you want to look at, when the builders want to look at the ROI for these investments, this will make sense. If you are saving more water in winter and your water consumption in winter is coming down, that will have a much bigger ROI and all. So it's very important to look at around the year consumption. Fourth step is rainwater harvesting and supply it as freshwater makeup. So this is, as I already shared, that how do we store water for around the year consumption is something we need to work on. And there are a lot of different technologies for storage which have come into the market. There are synthetic media, structured synthetic media with linings which can store water. They're very strong. They are concrete tanks. There are different types of, and whether we can see one point which I was thinking, which I would like to share, is when we design the buildings, then we put a lot of dead weight, concrete dead weight, and the because we have large basements, and the worry we have as structural designers or architects is that because of the soil pressure when the soil is saturated, there may be an upthrust to the building, and the building may become shaky. So we put a lot of dead weight. So can we have this dead weight from water? If we have some, so I'm not an architect or I'm not a structural designer, but just a idea and a concept I thought I'll share. So yeah, there's an opportunity to innovate here. So of course, sometimes you can't meet all your demand with the rainwater, and that's when you want to look at seasonal variation of water quality, whatever water resources are available, what is the seasonal variation, and then look at the right technologies, design the treatment systems, and look at various possibilities of dual plumbing system, supply or discharge, and optimize your design. So I'm confident that if we do this, we'll see a different India, different cities, and we will not have to supply water from far off places. Actually, what is happening is when we pump water from far off locations, we are not allowing the local population to get benefit of that water. So this is also become a serious issue in some places in Maharashtra and all. So when we do all this, what is the impact on all these buildings, different types of buildings? So I've shared some numbers. This calculation we had done long time back. I just wanted to highlight the impact and the savings which we can have if we implement these strategies. The demands can come down significantly from, like, in the housing society, it can come down from 135 liters per capita to 25 to 30 liters, maybe even lower. 25 could be a right number, as I showed in my case study. Even the campuses, hotels, hospitals, you can have much lower freshwater demand. So I've almost come to the end of my presentation. I didn't want to make this too technical. Of course, if it has become technical, then Of course, I have tried to present it in a simple way, but yeah, if you have any questions, we can answer the questions. But I didn't want to really share the technologies, but just wanted to give you an overview of technologies. What are the technology options available with us as engineers? So we have conventional technology, age-old, proven, but sometimes there are high maintenance and a lot of monitoring is required. So, biological processes, UF, RO, MPR, different technologies we are already implementing. There are a lot of advanced technologies which are coming. So there are non-biological technologies. There are zero discharge technologies, chemical-free technologies, different technologies. Sometimes when we look at high maintenance, then we look at alternatives to high maintenance. So there are a lot of options available. And sometimes we also have green technologies also as an option. But green technologies generally need larger surface area. So the application could be limited in cities. So I hope I have been able to share the whole thought on net zero and so
sure.
Open to questions.
Sure, you have, Rajesh. Thank you so much.
Thank you.
I know you have made a very serious effort to keep it as simple as possible. But then the issues are not complex, but they need a certain kind of approach to engineering and design. Yeah. And well, you can't make it any simpler given 45 minutes that you had. Thank you so much for that. And to all of you students, I will share one observation which your mother, your grandmother, and others have often told you about. We are about the only civilization in the world which venerates water and not commodifies water. You look at a river in Europe or in the US, it's just another river. But in India, every river is Ma Ganga. 80% of us, 800, 900 million of our people who are the soul of India, respects Ganga Mai. And your mother would have told you, your grandmother would have told you, when you want to waste some water, she will say, Paap lagega aapko. Please remember, therefore, that this is one rare civilization which has known sustainability in its veins, Dr. Jain used to say this, that if there is a Jagat Guru of sustainability in the world, it is India. I want you to remember that. The other is, I want to make a small announcement of which you will find on the Prem Jain website soon enough. The Indian Plumbing Association has launched, about a year ago, it launched what it calls the I Save Water Mission. I think Gurmeet Singh Arora is there on the group just now. He will be invited one of these days, into one of these weeks, let us say, to offer you a presentation on what this I Save Water Mission is about and what you as students, with the help of your faculty and probably people in your neighborhood, can do to make such a mission real for your city and town. Rajesh, for you now, I'll start with some of these questions. Let me also tell you all that we cannot answer all the questions. You have asked some very, very discerning questions. I can see some senior professionals raising these questions. Thank you for raising them because it helps the students to understand better. All I will say is, while Rajesh will, of course, try to see what he can offer as explanation or clarification to your questions, we will respond to all of these questions in detail. I promise you that before Sunday or Monday morning. And you will see it on the website at the same link that has been posted on the chat box or will be posted soon enough by Debarti. Questions for you, Rajesh. I'll start with, what could be safe alternatives of using RO systems for treating water? And what do you do with RO discharge water?
So, as I've already shared that, I'll try and give a slightly broader answer that when it comes to softener, of course, you're talking about RO, but I'm also talking about RO doesn't add to the TDS. RO only splits the water into two streams in general. And sometimes you are forced to use this RO because you have a high TDS source water and you want TDS in the supply water to be in the range of 200 to 300 ppm. So that's when you need to actually go for a second stage RO and optimize your design and recover the reject water RO by using appropriate technology like MPR is one of the options.
Can you explain, Rajesh, to the students, if TDS is, let's say, as high as 2000 or 2500 ppm, when it comes to borewell water, what is the risk of drinking such water?
So Yeah, so when there is high salinity, you don't want to drink water first of all. So you will actually dehydrate because you will drink less water. The water is not tasty. And second is you may have problems because of high salinity. You may have diarrhea or these kind of issues. So that the norms which are set are less than 500 ppm.
Okay. Some of you people who are living in apartments, you will know that when you get water from tankers, for example, and it's happening in, not so much in Bombay, but it's happening, I know, in Pune too, very much so in Bangalore. That water, which comes from a tanker, typically has over 1,500 ppm. Sometimes it's up to 2,500 ppm in these months of summer. Now, potable water cannot have, Rajesh, correct me on this, cannot have more than about 150 ppm as TDS. This, what people do, therefore, is to combine, as you said, with a softener also. Can you explain that?
Yeah, so, softening, lot of us use because we don't like hard water, using hard water in bathing because it spoils our hair or, our plumbing fittings and all. But let me tell you, soft water is not good, not desirable because of excess sodium. It is not desirable for drinking. So as far as possible, I always recommend that avoid softeners. If we can do a good design without softeners, it is always better.
Okay, one very nice question for you, Rajesh. Rainwater storage sumps of very large capacity should be made compulsory. A person called N.R. Ashok is writing. Only then rainwater can be stored and used for longer periods, especially in the non-rain months between December and say April or May, depending on which part of the world you're coming from. I mean, of India you're coming from. Yeah. The second observation he makes, and 3 or 4 others have also made this, flow meters should be made compulsory. Why should people who use less water be made to pay for more water used by others?
Yes, absolutely. So I was hearing a lot of fights within the societies on this issue in Bangalore and Hyderabad, and a lot of the societies have started going for flow meters as a retrofit, which is a big challenge. So I would definitely say that flow meters should be added in all our designs for each house. And storage, of course, since the costs are high and there may be constraints, but yeah, it will make sense because one-time investment, and if government can give some incentive on storage, cost of storage of water and all, it will definitely make sense.
Sure. One very interesting.
So when I was looking at the volumes of storage is required, so you can rationalize your design. You can go for a 3-month to 6-month storage instead of a full year, round the year storage.
Sure. There's another very young builder. He's from Bangalore. His name is Suhail Rahman, and he has consistently sought to build platinum-rated buildings. His question to you is, and it's based on an observation you made, when you reduced in one of those case studies 230 KLD to 39 KLD freshwater requirement, did it also include the health grade level recycling, or did it not?
Yes, it did.
It did. So his next question, therefore, is, if it did, was it an RO system, and how much of it was RO water? Now, let me explain that before Rajesh takes over, Suhail, for you and for the rest of you all. In any of these systems, they are based on technologies that have come from about 2005, when human genome sciences or genomic sciences brought in certain kinds of understanding of human genomes. By 2014 or 15, the technologies got disrupted on cost also to a point when it became affordable. Now, China took to it, Singapore took to it much earlier, of course, to a point where, the systems for treating such water combines a little bit of RO. About 15% of the water is RO. We can explain this offline, or we will have a more elaborate answer or response put in on the website by Monday, as I said. Rajesh, do you want to add to this?
So it will totally depend on your TDS. So if your TDS is low, if you're managing your TDS well, which we can actually do a case and explain how that can be manageable. So if your TDS is low, you need not have an RO. You can have a much simpler technologies. But as Dr. Hariharan mentioned, yes, sometimes a partial RO will be desirable, and the reject from the RO need not be thrown out. Can be used in the horticulture. Yeah.
That's right. There one question for you from a person called Devraj Reddy. Can you explain detail of the LPCD as per, let's say, NBC? The other is, if you have a green rated building, what would that LPCD become? The liters per capita per day.
Yeah, so I think the general norms I've already shared in some of the buildings, and if you, I've again shared in my last slide that if you conserve water and
Yes.
recover all the water wastages, it comes down
Yes.
by almost 85%. 80% it comes. Yeah, it is only 20% of the government norms.
Sure. There's another question. I don't know if this can be taken up from a very senior professional called Mohan Iyer from Bombay. What is the estimated evaporation and blowdown loss in cooling towers? Is there a thumb rule of measuring water loss per TR of cooling?
Yeah, it is 1 to 2 liters. Typically 1 to 2 liters per TR.
Explain that a little bit more, please.
Yeah, so when I said 8 to 10 liters as the makeup water required for air conditioning, almost 5 to 6 liters, approximately 6 liters goes in evaporation, and 1 to 2 liters is a blowdown. So actual requirement sometimes is around 8 liters, but because of other losses and sometimes because of poor instrumentation, we normally take 10 liters as the design stage.
So when you say 10 liters, you mean 10 liters per TR per hour?
Yes, yes.
And typically an air conditioner will run for about 16 hours in a building.
Hours, yes, absolutely.
Yeah, if I have got 100 TR for a centrally air conditioned building, you are saying it will become 100 into 10 into 16.
Yes, absolutely.
Please note, all of your students, you might be architects, you might be engineers. These are basic thumb rules that come from experience and understanding with doing of projects of the kind that, let's say, Rajesh has done and many others have done. Now, another question for you. Is there some focus that you can offer on embodied water in products? For example, let's say I buy a chip for my computer, or I buy a smartphone. What is the cost of water in the manufacturing of the chip that embeds in a smartphone? Well, let me answer that. Typically, the water quality for chips of that kind that we all use, Intel makes them across the world. They make them in China. India refused to allow them to come here in 97, 98 because it needed water of a quality that comes at about 3,000 meters ground, below the surface of the ground. Now, that depletes water ecologically so disastrously that India decided not to offer its environment clearance. At that point of time, Intel went to China and decided to take it up there. To every smartphone that you buy, there's about 30,000 liters of that quality water that is needed. I won't explain more. You can check this out on websites. There's much that is available as text. Please read that. And every time you buy a smartphone, remember that it costs you about 30,000. Now, I could take examples in cars, for instance. Architect Sakshi, for instance, has done some extensive studies in the University of Bath when he was there as a postgrad on carbon. And carbon is related back to, of course, such embodied use of either energy or of water. These new concepts called water G, or water and energy combined, Padhu Padmanabhan has been doing a lot of frontier work in that area. I know Rajesh Jain has been also trying to see how we can do some such work with state governments. And how do you do water budgeting, for example, is another challenge that will come up when you talk about embodied water. 1 kg of rice that you buy is about 4,000 liters of water. 1 kilo of sugarcane that you buy is about 13 or 14,000 liters of water. That is the embodied water principle. Please read about it. If some of you want to do a thesis on this, please come back to us. We will help you and guide you on this. Next one for you, Rajesh. With the coronavirus now found in wastewater, recycling solutions will have a harder time unless the solutions can show that it removes virus also. Do your current wastewater treatment solutions do this? What are solutions you will suggest? This is from Karthik.
Yeah, so, of course, there's a fear and concern that, we may have coronavirus in the incoming sewage in the plants. And how do we avoid exposure of operators and all, because it will then impact the whole society. But there's again a confirmation that if you treat your water well and chlorinate, that the chances of coronavirus going into your treated water is not there, almost not there. But then as a precaution, there are now UV systems available, ultraviolet disinfection systems, which is a UV lamp with special design, which can actually make sure, and they are certified also for these viruses.
Okay, one more very simple question from a lady called Rashmi. STP treated water, can it be used for car wash?
Yes.
I know it's a simple question, but please answer it.
Yeah, yeah. It is already being used in some of our projects. Yes, because when you treat the water to very high standard, BOD less than 5, then you can actually see BOD less than 3 is the human contact standard. And when you do the car wash, you need to touch the water and all that. So I would recommend that we follow those standards, and we can definitely use the water for car wash.
Okay, on water technologies, one question is, well, there are so many technologies, obviously, that have come for both managing demand side and supply side. For example, flow meters. Yeah. Is there some certification process whereby we know that what we are buying is also green as a product? Well, my answer to that, let me take this. There is something called Green Pro, a certification process that the IGBC CII has been offering. Please check their website, look for Green Pro. And you will see about 800 or 900 products just now, which have been certified over the last, say, 2 years or so. A wonderful veteran among us called Parasuraman. He's now the chairperson of that rating for products. I will leave it at that and probably answer that question in a little more detail when we host it up on the website by Monday. Question to you, Rajesh. I'm sure with your experience of so many projects, you will be able to answer this. There is, Sunil Agarwal is the person who is asking, there is stigma in using gray and black treated and recycled water. How should people be convinced to bring them on board?
So, we don't trust, our systems and operations, which is true. And that's why people are now going for online monitoring systems. You can have water quality alerts, you can have water indexing done, and below a certain level, it will give you an alert. And when you take sufficient, safety measures, more or less you can rely on the water quality.
That's a very engineering response to it. Okay. The question, the more important aspect I think Sunil is asking about is, how do you convince people that water that comes off their toilets and systems like that can actually be treated and become drinking water? China has done it. Singapore has done it. Why is it that we can't convince people here?
So I think I know of many case studies in India also. There are almost 5-6 buildings which are trying to implement. One of my friends in Bangalore, he's again bid by Dr. Hariharan. Long time back, he was very convinced that, they are going to recycle all the water and drink it. Even as an engineer, as a practicing engineer, I was telling him that this may not be safe for children, but he did it many years back. So I think it's just especially when our water resources are getting polluted, how sure are you that whatever fresh water you're getting from your borewell or from any water supply is safe? Even you're not sure of that.
Yeah. Effectively, all of your students, I think what Rajesh Jain is saying is that such change, we always resist such change. Anything that is new is feared. And the fear can go only when you rationalize and ask all the hard questions and get very, very convincing and satisfying answers. So there is not so much social engineering here as much as technological engineering. So you have to ask your questions. All the most difficult, nasty questions on this have to be asked. And as you get satisfied with them and test them on a proof of concept. So you don't have to do an entire apartment. You can say, okay, I will do it for this block of maybe about 20 flats, and then decide what it can mean. I'm just giving you a very random example. But there is a way of possibly doing such proof of concept and then taking it forward. Even better, visit all those, apartments. He took one example. There are quite a few of those, I think, that have happened in recent years, and find out what they have done and how satisfied the users are. That is the only way to go forward on this. One more question for you from Sunil Nandipati. He's always been asking some very good questions. Can we make the net zero water principle apply during pre-construction and on-site construction?
Net zero
water.
I'm not sure. I'm not sure of this because
fair enough. Yeah. Let me put it this way. Very, very brief response to this. If you used construction materials that can reduce curing water, for example, if you used materials that use less embodied water in their manufacture, for example, look at let us say tiles. There are natural granite kind of forms that you can take, or you can take these synthetic tiles that are available, or vitrified tiles. So what is the embodied water in the manufacture of vitrified tiles? If you are from Ahmedabad or some parts of Gujarat, you know that about 40, 50 kilometers off Ahmedabad is one large area which has been known for such vitrified tiles. So you have to ask those questions on embodied water efficiencies, of course, what embodied energy efficiencies, before you pick the materials. And that is where buying of certified green products will help. I'll stop there for now. And I'll ask you another question that has come up, interesting one. Currently, we have more treated water. Rajesh, look at this. Yeah. Currently, we have more treated water from our STP than we can reuse. You did mention that, but since he is asking, I'll take this. One issue is because regulation currently doesn't allow for portability of treated water, he says. That is, if I want to do a health grade water system, regulation doesn't permit me, is what he's saying. Is that true? The next part is, how can we have this regulation changed so that at least 50% of treated STP water can be utilized for health grade water?
So are we talking about India in this? This is
India, clearly India. Yeah.
No, so in my knowledge, there's no regulation which can prohibit you from recycling the water.
Absolutely.
Yes, there is a regulation. If you may not be allowed to recharge the water, STP treated water, because the government has a concern that if your STP is not working well, you may contaminate the whole of groundwater resource.
Absolutely. Rajesh is right, Karthik. And please remember that if you are living in an apartment, you already have an STP system. Of the discharge water, that is the water that is coming off all these homes, you would have used up about 40%, I would think, for car wash, for gardens and such. The other 60% is the water that you say that is in excess and that you have to, just drain into the stormwater drains outside. If you were to install this fourth level water treatment system, you will have sorted that problem. And let me add once again, I had said this a little before, Rajesh also had emphasized this. Any investment you make in these areas today, if you don't have an STP and let's say you have put up an STP, you have an STP and you have now put up a health grade water, you can see that your investment will be paid back in less than about 3 to 4 years. You can check with people that you want to, or you can write to us and we will see how we can explain these things to you. Next question for you. Some 3-4 people have asked, therefore I'm taking this up with you. In about 5 to 7 minutes, we will close this. The question is this: is it possible to adopt metering for existing apartment complexes and make it mandatory?
I think now I was already sharing the examples of Bangalore and Hyderabad, where there is a lot of infighting in the society and people are now implementing it and also finding it very useful. So yes, making it mandatory lies with the policy makers, and it should be done. I would say that it should be done, yes.
It should be done.
What is happening is the water is still not priced well in India. So, we always correlate the metering with the pricing, because when you are metering it, then you want to price it. So that's where we need to really work on. Sure.
But that scenario has changed a little bit in cities like Bangalore, because they are buying water at 150 rupees to 180 rupees per 1,000 liters. In summer, just now, people are buying at 300 rupees per 1,000 liters in some parts of Bangalore towards Sarjapur Road and such. If you're from Bangalore, you'll understand what I'm talking about. Question to you. You didn't actually answer this question earlier, so I am reiterating this. This is from a lady called Neha Vyas. What can be done with RO reject water? Can it be reused?
Yes. So if you, again, as I shared, if your raw water TDS is not very high, you can actually play with your design such that your reject water TDS is within 2000 ppm, and you can use this water for horticulture. This is one case. Second case, when you have a lot of excess high TDS water which you can't use, then you have to go look at technology which can actually separate the salt and water and recover the water.
Fair enough. He will explain this to you in greater detail on the website by Monday. Nivedita Sharma, she wants to know, she wants to know if drip irrigation is valuable. I mean, Nivedita, I'll put it like this to you. Your question is, drip irrigation was, or an observation is, drip irrigation was invented by Israel. Let me put it this way to you. We are about 120 million farmers. With dependents, they become about 350, 400 million Indians. The wisdom that our farmers have on how they can manage cultivation water with good management of seeds, for instance, is phenomenal. you have to go visit villages and understand how technology, which is, let us say, 500 years old, are a lot more superior and efficient than what you will find as current modern day technologies from other places. So let's not be bought in by other technologies. Like Gandhiji said, let's keep our windows open, but let's not get our house blown away. We must understand and take pride in the multiple sets of such wonderful understanding and ancient wisdom that we have on water management in India. And I think that needs a lot more understanding by young students like you, who will want to make careers not in, in architectural practices, but in going out to the other India and learning and offering your knowledge, your training for their betterment. I will then, there are very few more. One large one, this is again about why can't we stop growing crops that need so much water? Do you want to answer that, or do you want to leave it there? It's a good question to ask.
Yeah. No, it is already, the governments are concerned. I know Punjab is concerned about this because the groundwater is depleted badly in Punjab because of, especially because of growing paddy, and paddy was being supported in the MSP minimum support price. So everybody went for paddy. So government is thinking a lot in terms of what is the right policy, how do we support the other crops which are less water intensive. A lot is going on in the,
Absolutely. Rajesh is very right. It's a larger debate, and I don't think we should engage here with the time frame that we have got. One question from somebody who's anonymous, and I'll request all of you who are making this anonymous questions out there to put in your names. It helps because others want to know what your names are. And when we respond to you, to your questions on the Q&A at the website, we like to put your name there. So the question from this person, anonymous, is, if there is an AP rating program from IGBC for building ratings, is there a similar training program for water and such? I would like to think that's the question. Let me answer it this way. There's nothing specifically for water like that, but there are a lot of training programs for green buildings from the IGBC. You can look up their website, just go to igbc.in and keep looking for training programs that are coming up. And if there is one in your city, you can take it up with those people. So please, for all of your students, I'm saying that once a week or once in a fortnight, it will be useful for you to visit the igbc.in website and read whatever you want to read. There's a host of information that has been put up there, just as we are now putting up at the PJMT website. It's now 12:05. Any last notes that you have, Rajesh, that you want to offer them all before we sign off?
No, so I would say that now cities are becoming denser, and the opportunities, we will be losing opportunities if we continue to, discharge water and not try and implement proper designs, and also look at existing buildings. It is very important. A lot of our societies do not have STPs, and we don't want to have STPs because we feel STPs will smell. We don't want to have STPs next to our houses. That's not true. You really need to choose the right technology, right vendor, and make sure that you are implementing the right things and operating and maintaining the systems well.
Right. For all of your students, once again, I told you about the iSave Water Mission, and we will offer you more details, not the time. There is another champion, a green champion of maybe 40 years, a man called Niranjan Khatri, who has been running a very simple campaign for at least the last 3 or 4 years. An extremely passionate person. Like Rajesh correctly pointed out, sometimes you may be very passionate, but you don't have the direction. Rajesh found his direction when he met Dr. Prem Jain, fortuitously in 95 or 96, when he was a young engineer. What Niranjan has devised is, whenever he goes into a hotel, he tells, and he spent 40 years in a very large hotel chain. He insists that water poured in a glass is only 1/2. Now you could do that in your house. You could do that in your hostel, in your canteen. Please do not take a full glass of water, sip some 3-4, let's say a quarter of it, and drain the rest. Do not do this. Like your mother told you, paap lagega aapko if you drain Ganga Mai. So this is a message that that is very powerful and very important. And I'm glad also to say that his original mission of maybe 3-4 years ago has slowly changed, morphed into many hotels. I know many hotels today where they'll give you only half-glass water. Please remember this and see what you can do. Last question, will we get a recording of this webinar? We have said this repeatedly to you all. recording is available. The link is also been put up on the chat box. Go to the PJMT website, look for Living Building Series, and you will find it. As for the next edition, which is coming up the next Thursday, May 7th, same time at 10:30, we will have a wonderful, extremely wonderful resource person called S.R. Kumar, who worked for 20 years in Caterpillar and other companies in Canada, came back to India for his love of the country, and decided that he will dedicate his life to making an enterprise which will convert waste to wealth. He's now over 6-7 years, he's been working on it here, and he's an IGBC member. He's also a very senior member of what is called the Indian Biogas Association. And he will present to you some very, very fascinating aspects and elements of how you treat waste in your house, in your apartment, in a hotel, or in a city, you know, and that will be for the next Thursday. There's a lot more to come after that in the Living Building series. And I'm very glad today that so many members, senior members of the IGBC are present on this platform. Students, once again, I will urge you all to read those reference reading sections. If you want to have very specific case studies, you have to read and understand those and ask more questions. Today you saw how Rajesh sir told you of many things that you could possibly implement in your own apartment, or try this after talking and securing the guidance of your faculty of how you map the water requirement in your campus, in your college. That will be a great starting point. Rajesh, if you don't have anything more to add, I think we should sign off now. And yeah, thank you so much once again to all of you all. And look up those things as links have been offered, and come back on the questions that have been asked of you under the reference reading sections. We'll sign off now. Thank you so much. Thanks for all of you. Thanks Debashish and Debarti, as well as architect Sakshi Jain, Payal Jain, and others who have been making this wonderful event happen week after week. Yeah.
Thank you all.
Thank you. Yeah.